Here's actin. Actin polymerizes, depolymerizes, just like microtubules. This one's 7 nanometers in diameter, whereas microtubules were 25 nanometers. If I'm not saying anything, that means there's nothing to know yet. We just can't do it all. Do you remember seeing that in the film? This was gray, and I think these were yellow. But did you notice that angle? It was always at 70 degrees. Actin does that. It makes this cross-link inside the cell. If you go back and look at that video at home, you'll see that very same thing. Oh, crikey, that's so interesting. What I just took off was everything in H, as in hair, H. That dealt with, wait a minute, did I took off F, which was actin binding proteins. I'm sorry, it was not H, it was F. As well as E. I took off E and F on your outline. E was drugs which affect actin. F was actin binding proteins. That's one of them. We're not going to talk about it. Okay? Nothing to memorize here. This is just another protein that links the actin together. We're not going to talk about that. These are skin cancer cells in one case and not in the other. And I'm sorry, they are in one case, they're both skin cancer cells, melanoma cells. And because of a presence or a lack of this protein that links actin filaments together, they are either able to migrate, in other words, metastasize, or not be able to. Not responsible. Not responsible. Not responsible for, not responsible for. That's an amoeba crawling. Alright, that was very briefly active. This is intermediate. This is horrible. Intermediate. Intermediate is the one that's weird. Because you don't have these little subunits that go together and nucleate and then polymerize, depolymerize. Instead, you start putting things together as pre-made little peptides or proteins. I don't even want to go into this. This is absolutely fascinating, darn it, but you can't do it. You start off with one of these peptides. You stick another one with it, going in the same orientation, and that forms something called a coil-coil dimer. All I want you to do is put that in the back of your mind and remember it, because if you go on and take other courses, you're going to hear so many things about coil dimers. But you don't have to do it for me. Then you start putting the 2s together to make 4. It's a tetramer. Then you put the 4 together and make this big rope-like thing, which is the intermediate filament. This is what you go in and you find a serine, you phosphorylate it, and what causes that, what happens then in the lamins? Yeah, the nuclear membrane breaks apart. So you can picture that as being a little serine right there. That's lining the inside of the nuclear membrane. Wow. You went through it all out. How sad. Okay, the last one's the ECM, extracellular matrix, and we're going to have to just hit the high points here again. Okay, so what are we talking about? We're talking about extracellular, outside the cell. So this is all that stuff that's outside the cell. That is the extracellular matrix. So this is showing you that there are two types of tissue in this cartoon at least. There is epithelial tissue shown up here as the epithelium. Epithelial tissue always rests on a yellow line. It's really not yellow, but on a yellow line in Albert's, it's always yellow. And that is called your basal lamina. Do not ever call that the basement membrane. And you will have happy instructors call it that. This is not a membrane. But the basal lamina is the resting place for epithelial cells. In the same diagram, you have connective tissue shown here. So epithelial tissue versus connective tissue. All of this is connected. And if you remember your connective tissue and the origin, if you go all the way back to your embryology, this is going to be stuff like blood is a connective tissue. Totally blank. Muscle is a connective tissue. So anything like that that's not lining an organ and that fits the other constraints is considered to be connected. And you have to go back to your different germ layers and so forth, which we won't do. Okay, so what's out here in this connective tissue? This is outside the cell, and what we have out here is a region that, in my mind, it looks like styrofoam. So you're looking at a cell. Here's the cell. Here's the cell. No, here's the cell. This is better. It's round. Here's the cell. So everything out here is, to me, almost like styrofoam. That styrofoam material is really just going to be very special, almost like sugars. They're not quite like sugars, but some of you may know about hyaluron sulfate and chondroitin sulfate. Have y'all heard of those? These are the things you take if you want to, some people say it improves your joint cartilage.
Yeah.
I know what I'm talking about.
Yeah.
Okay.
Get it from the health store.
Yeah. Yeah, studies show us really you're just wasting your money. Anyway, I shouldn't say that. Okay, so that's the stuff out there. In that stuff, you still have proteins. They can't be made outside the cell. So how did they get there? Secreted. Good. Joseph gets a star. They got secreted. Remember those 3 places you can go when you leave the Golgi?
Yep.
The default pathway. Okay. The big protein out there is collagen. So we are taking this extracellular matrix and we're going to break it into styrofoam and collagen. Right? Gray is like the styrofoam. It's got a name, and it has a name. It's actually, the acronym is GAGS, G-A-G-S. I'm not going to test you on this because I'm not doing justice to it. But the acronym is G-A-G-S, and that stands for glycosaminoglycans. That's the styrofoam. There are cells that will be secreting these things like collagen, very specialized cell. They are usually going to be fibroblasts. This is a cell, that white thing with the brown middle, that's a cell. That is a fibroblast. It will be making the collagen and secreting it. This purple line is collagen. This purple line is collagen. This is collagen. The green line is the elastin, elastic fiber made up of elastin. We are not even going to look at elastin. We are simply going to look at collagen. Okay? This is what it looks like outside that cell. These things that are clumped here are probably fibroblasts. I'm almost certain that they are. And this stuff that looks like Halloween netting out here is that stuff that I told you was glycosaminoglycans. These glycosaminoglycans have a very unique structure, which we can't go into, but they are basically sugar A, sugar B, sugar A, sugar B, sugar A, sugar B, sugar A, sugar B, repeating over and over. And that's what they mean about this repeating disaccharide. But we're not doing it. This is styrofoam. Okay? This is styrofoam, the white part. Oh, it's pathetic. So much cool stuff. All right, so now we're going to go to the one protein that we're going to look at outside the cell. Now listen to me very, very carefully. Collagen was made inside the cell. You guys know what collagen is, like your Achilles heel? It's nothing but collagen cross-linked. Would you want that inside your cell? No. This is what tendons are made of. You don't want it inside a cell. But we make it inside a cell. So we're going to see an interesting pathway that you are responsible for. So collagen is found outside the cell in its active form. Its active form means that it's cross-linked, but it was made inside the cell. So we are going to look at two things. One is the structure of collagen, and two is going to be the way it got out there. So let's look at the structure. 14, you want to study that slide. So focus on slide 14, slide 14. Okay, collagen is always, 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 always made up of glycine XY, glycine XY, glycine XY. Glycine, if you think back to your amino acids, is the baby. It's the one that is the smallest amino acid. So the glycine hides. See that darker red? That's glycine. It hides in there. And then your X and your Y are usually hydroxyproline. It's just a proline that's been played with, and a lysine that's been played with. We're going to leave it at that. Hydroxyproline, hydroxylysine. Usually, it's what the X and the Y are. G is always glycine. So it's GXY, repeated over and over. So what it does is make this helical structure, and then you take three of them and you put them together, and there is your collagen. So every time you look at a type of collagen, and collagen gets named by a Roman numeral. Like there's collagen type 1, Roman numeral 1. Collagen 5, Roman numeral 5. It will tell you that 2 strands are blah, blah, collagen, and 1 strand is blah, blah, blah. So you have all these mix and match possibilities. You don't have to know any of those. It's just you mix and match the strands to get the particular collagen you want for that tissue. This is collagen outside there. Just show you images. This is what I meant. See how these are different flavors of collagen. Those are the Roman numerals, like type 5. Well, if you look somewhere else in your book, it's obviously not here, you can go in there and find like 2 alpha strands, 1 beta. It will just tell you the makeup of those 3 strands. Okay, this is what X and Y usually are. So it's just lysine with an hydroxyl or proline with an hydroxyl. Here we go. Now this is going to be active collagen, so this is where we're headed. We do not ever, 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 ever